We can see that it is important to understand hydrologic investigation to prevent extreme drought and flooding caused by rapid climate change in recent years. Hydrologic investigation consists of 6 items: precipitation, water level, discharge and sediment, evapotranspiration, and soil moisture. Today's lecture is on the discharge measurement, which is basic and important items. Discharge means the volume of water that passes through a cross-section of river by measuring water depth and velocity with various hydrometers. Let me introduce some methods to observe discharge.
To start with, let's define discharge. Discharge refers to the amount of water passing through a certain cross-section over a unit of time. The discharge measurement is the basis of water resource measurements and the first step to establishing a national river basic plan. It means that taking proper and accurate measurements are critical. It is not easy to handle various measurement devices because so many different types are used depending on the situation on the site. Incorrect measurement results from incorrect operation can lead to irreversible situations. Therefore, the on-site worker should always be in the habit of carefully checking the measurement equipment and be able to use the measurement equipment correctly. We will explore the rotating current meter, ultrasonic current meter, and microwave surface current meter, which are the most widely used among the various types of discharge survey measuring equipment. Let's take a look at what we will learn today. With today's content, you will be able to explain about discharge measurements using a rotating current meter, ADCP, and a microwave water surface current meter. Shall we start now? First, let's find out how to measure discharge using a rotating current meter. A rotating current meter is designed to make the rotating speed and current speed proportional in the rotating part. The meter calculates the current speed using the number of rotations in the rotating part for a certain period of time, with the kinetic energy of a river. Field workers must wear personal protective gear to prepare for safety accidents. Personal protective gear includes safety helmets, safety boots, gloves, life vests, and whistles, and they have to wear waders if the water level is high. The rotating current meter is composed of the main body of the current meter, sounding rod, user terminal, and cable. The first thing to do on site when taking the current measurement is always to identify the features of the monitoring points. Wading measurement is a method by which the on-site worker directly enters a river. Because it is risky for exposure to water depth, current speed, etc., the measuring points should be carefully selected with safety management as a priority. Having identified the measuring points, the transversal line should be installed to set the water surface width and gap between the measuring lines. The transversal line is made of high tensile strength and low sagging materials and should be installed in an orthogonal direction to the stream flow. To assemble the rotating current meter, the sounding rod is assembled first, and the main body of the current meter is fixed on the assembled sounding rod. While fixing, it should be careful that the current meter does not fall out of the sounding rod. Finally, the protective cover is assembled to the bottom of the sounding rod. After assembling the main body of the current meter, the on-site worker wears the user terminal and connects the main body of the current meter to the user terminal using the cable. After installing the transversal line and assembling the current meter, the user terminal is set to default. When turning on the terminal, the measurement unit, method to measure the current speed, and measurement time are set. Then the measure checks and records the start time of the measurement and the water level. Having completed the default setting of the user terminal and checked the water level, the measurement of the current speed starts. Since it should be measured by changing the monitoring points according to the water depth of the stream, water depths at the monitoring points are checked with the sounding rod, and then the measurement of the current speed starts by adjusting the installed location of the main body of the current meter. Start with the measurement of the current speed and make sure to face upstream. When measuring the current speed, the sounding rod should be installed vertically to the river, and the current meter is set to be located in the direction of the flow of the river. The discharge measurement using the rotating current meter has different measurement times depending on the current speed. If the current speed is less than 0.2 meters per second, it should be measured for more than 120 seconds. And if it is more than 0.2 meters per second, it should be measured for more than 40 seconds. The on-site worker records data continuously flowing the marks at regular distances on the transversal line. When the measurements are finished, the final step is to click the user terminal button. When the measurement ends, the on-site worker should check and record the end time of the measurement and the water level. Once the current speed measurement is finished, discharge is calculated using an ISO standardized program or a system. The result values must be evaluated in terms of validity. Now let's take a look at the second type of measurement device, ADCP. ADCP stands for Acoustic Doppler Current Profiler and is an ultrasonic current meter that measures discharge using ultrasonic waves. Discharge measurement using ADCP basically utilizes the Doppler effect. A sensor mounted on the ADCP transmits ultrasonic waves of a certain frequency into the water and collects echoes that are reflected when bouncing off floating particles. The total discharge is calculated by measuring the distribution of the current speed by the water depth, using the time difference of echoes going back at this time. For the ultrasonic current meter, ADCP, there are various types: River Surveyor S5, River Surveyor M9, Rio Grande, Stream Pro, River Ray, and River Pro. Boats types that can use ADCP are remote-controlled boats and boats for towing. The discharge measurement equipment using a remote-controlled boat is composed of a boat, sensor and communication box, controller, GPS, and laptop. We assemble the ADCP equipment ourselves. ADCP is mounted on the front part of the boat using pins so as to ensure it does not move. Since the sensor protrudes under the boat, the on-site worker should be careful not to scratch or bump it. For the GPS, first connect the GPS stick to the sensor. Using a cable, connect the GPS with a communication device. Installing a communication device on the back of the boat and connecting it to ADCP through a cable. Next, the on-site worker installs an antenna on the boat for transmitting measurement data. Next, the battery is mounted on the boat. When turning on the power, you will see the on light and remaining battery charge. When pressing the power button of the communication box to turn the ADCP on, The light comes on at the top of the communication box. After connecting the communication box and touching the top of the battery with a magnetic stick, the side will light up. The green light indicates normal operation of the boat and communication box. If the red light turns on, it is a signal that there is something wrong with the equipment. Thus, the equipment should be checked again. Next, we connect the receiver to the laptop using the USB connector, and then we raise the antenna and run the operating program. The discharge measurement equipment using a boat for towing is composed of a boat, sensor, communication box, GPS, and laptop. We assemble the ADCP equipment ourselves. We install the ADCP on the back part of the boat and pin it so that it does not move around. Since the sensor protrudes under the boat, the on-site worker should be careful not to scratch or bump it. For the GPS connecting stick is connected to the sensor first. Using the cable, we connect the GPS with the communication device. Next, the on-site worker installs the communication device to the middle part of the boat. The device is connected to the ADCP with a cable. Then the antenna is installed on the boat for transmitting measurement data. The receiver is connected to the laptop using a USB connector, and then we raise the antenna and run the operation program. The discharge measurement program dedicated to River Surveyor M9 is River Surveyor Live. When you click Connect to System to connect the sensor after running the program on the laptop, select a system that finds the sensor and connects it. If the system fails to detect the sensor, you should do the search again and check if the power of the sensor is working. When the connection is completed, you will see the Start screen and can set up the system. Please set the time by clicking Set Time. By clicking System Test, you can check the operation. By clicking Site Information, please input the information of the measuring points. By clicking Compass Calibration, you can start the calibration. You should calibrate the ADCP equipment for accurate measurement. This is because the intensity of the Earth's magnetic field varies from place to place, which can affect the internal compass. Compass calibration requires that more than 2 people calibrate it by moving the equipment for each discharge measurement, and if an error occurs, recalibration should be carried out. By clicking System Setting, you can enter initial information on the sensor, such as salt concentration and water depth, in which the sensor is submerged. When the basic settings of the operating program and sensor calibration are completed, you can start the system by clicking System Start. First, since the edge of the water is low in depth and cannot be measured, please click Start Edge to enter the separation distance, which is from the starting point of the water edge to the measurable sensor, into the operating program. Here is an example of what the operating program looks like. After checking the distance of the installed boat and the separation distance input into the laptop's program, start measuring the discharge by moving the boat toward the target spot on the opposite side. This slide shows the remote-controlled boat. This slide shows the boat for towing. When the movement of the boat is completed, enter the separation distance from the edge of the water at the destination point to the measurable sensor. Check the separation distance and input into the laptop program to complete one discharge measurement. Here you can see an example of the laptop program. Discharge measurement should be performed more than twice with a round trip to minimize errors, and the results obtained from these measurements will be found in the laptop's dedicated program for discharge measurements. For the results of the discharge measurement, click Show, Hide Discharge Summary in the Program menu, and check the data, such as river width, cross-sectional area, and discharge. The measurement results should be managed using tools such as the Survey Performance Management System, and the validity of the measurement results should be reviewed. Now, we will take a look at the third type of measurement device, a microwave water surface current meter. A microwave water surface current meter measures the current speed using the Doppler effect of the microwaves. When microwaves are radiated to the surface of the water, they are reflected on the surface of the water, and some of the reflected microwaves return to the antenna. The returned microwaves can be used to calculate the current by measuring the frequency generated by the Doppler effect due to the movement of the water surface. At this time, the surface current speed is measured by using a characteristic that is proportional to the Doppler frequency and the transmission wavelength, and is inversely proportional to the communication antenna slope value. The surface current speed calculated in this way is converted into the average current speed using a developed calibration skill to calculate the discharge. The basic equipment of a microwave water surface current meter has largely three components: the body of the microwave water surface current meter, user terminal, and tripod. Additional equipment includes a 2-meter charging cable, battery charger, equipment carrying case, and tripod head. The method to measure discharge using a microwave water surface current meter is mainly adopted in the case of rainfall, so field workers have to wear personal protective gears for their safety and to prevent any accidents, and safety equipment on the field should be thoroughly built. Personal protective gear includes a safety helmet, safety boots, gloves, fluorescent reflective vest, fluorescent raincoat, and whistle. Safety equipment includes a signpost, life ring buoy, and life-saving rope, signboard, rubber cone, light baton, and more. Safety equipment should be installed to distinguish between the measurement area and the vehicle passageway and to protect the on-site workers. It should be manufactured and installed so that it can be seen from a distance at night. To install the microwave water surface current meter, first an adapter is mounted on the tripod head, and then tripod head is assembled. After adjusting the height of the tripod, the body of the microwave water surface current meter is fixed to the tripod head. The direction of the antenna is made to face the front of the body, and the 3 axes of the tripod head are also fixed. After installing the device, press the power button on the back of the main body. Connect the power of the portable user terminal and click the icon of the microwave water surface current meter to run the operating software. By running the operating software on the beginning screen, confirm that the software automatically checks the wireless connection status and the status of the current meter body. The on-site worker should check to make sure the meter is connected normally. If it is confirmed that the connection is normal, press the button of the measurement settings at the bottom. The on-site worker should set the measurement time, average current speed of movement, the number of repeated measurements of the average surface current speed, and the current speed display mode. Here, the measurement time is set to 30 seconds or more for one measurement to reduce uncertainty. When all inputs are entered for settings, please press the Completed button to end the setting. Additionally, please check and record the start time and the water level. The current speed is measured by changing the number of sidelines according to the width of the river. For sidelines, they are selected with more than 20 considering the precision and uncertainty of the measurement, and are deployed according to the width of the river. After checking the number of sidelines by the width of the river, the microwave water surface current meter should be installed. At this time, the current meter should be at least 40 centimeters higher than the railing of the bridge horizontally, and the head should face upstream. Having completed the installation of the microwave water surface current meter, please click the measurement button on the terminal. Then the measurement device starts. It will run automatically. When completed, the screen for saving data will pop up. Please select Yes. Then it brings up the Data Input screen. On the Data Input screen, please input anything specific, including data information, and press the Completed button to save the data. After one measurement, move and install the device along the measuring points indicated on the bridge, and click the Measurement button of the terminal to measure continuously. Please turn off the terminal by clicking the button after completing the measurements at the last point. And then, please check and record the end time of the measurement and the water level. For the saved measurement results, press the Data View button on the measurement screen of the terminal. You can see the results here. You should measure the measuring points to calculate the discharge by using the measured current speed. The cross-sectional measurement should be completed before measuring the current speed, using equipment that can survey the terrain, such as a light wave rangefinder. When the current speed measurement is completed, discharge is calculated based on ISO standards through a program or system. The operator must review the validity of the result values from the calculated discharge.